Okay, so we're ready to actually start programming how we can collect data and how we can reverse time in our reverse time component. So far we've only added this b reversing time boolean. We're going to add some more variables that we can work with for our algorithm. So I'd like to add another boolean, and I'm going to call this one b out of data. And b out of data will be specifically for when we are reversing time and we've run out of data to set the location, rotation, and angular and linear velocities of the object in question. So let's go ahead and give these some comments. So for b reversing time, we'll say true when reversing time, collecting data when false. We can actually say reversing time when true, collecting data when false. B out of data is out of time data cannot keep reversing. Next, we're going to add a float, and this is going to be called running time. And this will be keeping track of the time while we're going backwards. And so when we're reversing time, we want to keep track of the running time as we're going backwards. But then we also want to keep track of the reverse time. So we're going to make one called reverse running time. So these two kind of sound like the same thing, but they're not. And let me go ahead and demonstrate what I mean. So we might have a bunch of frames of data at any given point in time stored up. So here's one of them. Here's another one. Here's another one. Another one. Another one. So each of these is a frame worth of stored data. So say we were going forward in time, collecting data, and then all of a sudden right here, we decided to reverse time. So now we're going backwards. Okay, so now since we're going backwards in time, what we're first going to do is we're going to get this object, this frame package, and we're going to get its data, and we're going to set the object's location and everything else. Well, this data has a delta time stored for it. So since it has its own delta time, while we're going backwards, we're going to keep a running count of not only the real frame rate, because remember, time never actually reverses, we just give the illusion that it's reversing. So as we're reversing time, we have a running time, and that's going to be the actual time. Each frame we're adding delta time to this, the real delta time. But then we have our reversed running time, which is going to start at 0, and then after one frame, we're going to add on this delta time here. We're going to add on this delta time onto it. Then we're going to keep reversing time, so the next frame, we're going to get this frame package of data, and this one has its own saved delta time. And so we're going to increase running time by the real delta time, and then we're going to increase reverse running time by this saved delta time that was in the frame package itself. Okay, so we got two running times. One keeping actual track of time since we started reversing, and then one adding on the delta time each frame for each of these stored frame packages. So hopefully that wasn't too confusing, but this way we can keep track of the actual time that's been passing since reversing time. So we're going to comment this and say actual time since we started reversing time. And then reverse running time is going to be a running count of the frame package delta times. And so that way we'll know exactly how much time has passed, and then we'll also know how much time we are into the reverse time data. Okay, so then we're going to have another float, and this float, this is going to be the total amount of time recorded in our data. So we're going to call this recorded time, and I'm going to say this is the total amount of time recorded in frame packages. This is the sum total of all the delta times in the frame packages. Okay, and then finally we need our list. So we need a T double linked list. And this is going to store frame packages. I'm going to call it stored frames. So I'm going to go ahead and include up here at the top frame package .h, and I can't put it below the generated.h. Everything that you include has to go above that. Generated.h has to be the last one. So there is our double linked list. Okay, so this gives us some variables to work with. Let's go ahead and construct our algorithm. So this one is going to be a very sort of naive algorithm. We're sort of acting from the assumption that delta time isn't going to vary a whole lot, but then later we'll go ahead and take care of that assumption. But for now, let's get a proof of concept working. So the first thing we're going to want to do is we're going to take care of storing data when we're not reversing time. So we're going to say if not be reversing time. So if we're not reversing time, we're storing data. So I'm going to say storing data here. So the first thing I want to do is get the owner of this component. And the reverse time component, well, any actor component in general, can have access to the owning actor, and that is with the function getOwner. So I'm going to say a actor owner and call getOwner. This will get us the owning actor. And there is a convenient function to get all of the components of an actor, and we can do that with getComponents by class. And that getComponents by class will get all the components that belong to that actor and store them in a T array. And so what I'd like to do is create a T array, and it's going to be uActorComponent pointer. That's the type of, this is the return type for the getComponents by class function. And we're going to call owner getComponents by class, and this returns all a array full of components, and the argument for this is the class that we would like to specify. And I'd like to specify the uStatic mesh component, and this has to be a U class type, and so we can get that with static class. So what this gets me is the uStatic mesh component basically returned as a U class. And if you don't really know what a U class is, you can kind of think of it as like a blueprint, but in C++ code. So like it's like a reference to a blueprint type. And so this gives me a nice something that's compatible with U class, the static class. Now uStatic mesh component needs to be included up here. So we're going to say include components static mesh component .h. And while I'm up here, since I already know I'm going to use the frame package, I'm going to include frame package.h as well. And so what I need to do here is actually create the local variable. I haven't given it a name. So what I'm going to do is have this T array of uActorComponent pointers called components and set that equal to what's returned by owner get components by class. So once we have this T array of components, what we can do is first check to see if it's empty. So we can say if components.num for the number of components. If that's greater than 0, then we can continue. And what I'd like to do is, since I'm kind of assuming that there's only one static mesh component, if you in the future have decide to do multiple static mesh components, well, then you can decide how to handle that. But for now, I'm going to assume that these reverse time meshes, these actors that own the reverse time component, I'm going to assume they only have a single mesh component. And so I'm going to get that first element of this array. So I'm going to say U static mesh component. I'm going to call it SMC for static mesh component. I'm going to set this equal to, I'm going to cast to U static mesh component. And what am I going to cast? I'm going to cast the component's first element. So components of 0. And then if this SMC is not null, then I have access to that static mesh component. And we can actually go ahead and access the data that we would like to store. So what I'm going to store it in is a frame package, f frame package. And I'm going to call this package, and I'm going to go ahead and use the constructor that takes a bunch of parameters. It takes a location, so I'm going to fill it with owner get actor location. It also takes a rotation. I'm going to put this on the next line. And I'm going to say owner get actor rotation. So the third parameter is the physics linear velocity. So I'm going to call SMC, and it has a function called get physics linear velocity. And then finally, for the angular velocity, the static mesh component also has get physics angular velocity. And then finally, we need to pass in delta time. And that is the constructor for the frame package that we created that takes these parameters. So now we have a frame package struct that contains all the data for this particular frame. Next, what we can do is we can store that in our list. But first, I want to check to see how much time has been recorded. So I'm going to say if recorded time is less than 15.0f. And then we can store the frame, because if there's more than 15 seconds recorded, then we need to worry about taking some of the older frames off. But since right here recorded time is less than 15, then we can take our stored frames. Remember, stored frames is our double linked list. So we're going to take stored frames, and a double linked list can add to the tail, add to the end of the list, and we're going to add package. So once we add a frame package into our double linked list, what I'd like to do is take our recorded time and increment that by delta time. So that way, every time we add a frame to the list, our recorded time expands by the amount of time stored in that frame package. So that way we know exactly how much time is stored in our list. Now remember, we had this Boolean called out of data, and we're going to use this to know when we can not reverse time anymore. And if we've just added a frame package to our data, then we know we're not out of data. So we can go ahead and set be out of data to false here. Okay, so that takes care of if the recorded time is less than 15 seconds. But else this means that we have 15 or more seconds worth of stored data. So what happens when we have 15 or more seconds of stored data and we want to add data to our list? Well, what we need to do is remove something from the head of the list. And we can get the head of the list by using auto head equals stored frames dot get head, because the double linked list has this function called getHead, which returns you the item that is at the head of the list, the first one. So, and you'll see that it has the type T double linked list, frame package, double colon, T double linked list node, apostrophe head. Okay, so that's why I used auto, because that will just go ahead and give me that type by default. I don't have to worry about the type. But what I'd like to do is I'd like to get the delta time from this frame package that was at the head. So we got the head frame package. Let's get the delta time. So let's call this float head dt for delta time, and say head get value. And this function belongs to the double linked list node type. The node has a function called getValue, and so each node in a double linked list has a value, and that value is what that node gets set to whenever we add something to it. So when we add it to the tail, what we're doing is we're creating a node, and that node has data. We're passing in this frame package for its data. And we can do that because it's a double linked list with a template type specified to be frame package. So we've got our head delta time because we got our head get value. This gets us the frame package in the head node. And since we have a frame package, now we can get delta time from that frame package. So this is our head delta time. So what we need to do is now we would like to take recorded time and subtract off that head dt, because now we're going to remove this head node. So remember, getHead just gets us the head node. It doesn't actually take it out of the list, but we can very easily remove the head node from the list by taking our list, stored frames, and calling remove node. Remove node requires you to specify which node to remove. Well, we're going to remove the head. So here, if there is more than 15 seconds, this removes one of the nodes, and then it decrements the recorded time by the delta time of that frame package in that node. But this isn't quite enough, because what if this frame was really, really small, and the frame that we add on is really, really big? Well, we're not taking off that much, so if we have a lot more than 15 seconds, we're not really keeping it close to 15. So what we're going to do is we're going to wrap this in a while loop. We're going to say while running time is greater than or equal to 15.0f. And we're going to put all this stuff inside of that while loop. So this will happen over and over again until running time is less than 15 seconds. So that's what we're going to do, is we're going to first of all check to see if recorded time is less than 15 seconds. If so, good, we'll add the new frame package. But if it's not, then we're going to subtract off of the head of the list. These are the oldest frame packages. We're subtracting those off until recorded time is actually less than 15 seconds. After this, once we're done, once this while loop terminates, then that means running time is less than 15 seconds. Then we can finally add our frame package. So stored frames.add tail package. And then as we're adding the package, what we need to do is take recorded time, add on delta time to that. Because we're adding a new package. This package is the current one we saved at this frame, so it has the delta time of delta time. If we wanted to make this more obvious that this delta time corresponds to this frame package, we could simply say package.delta time as well. That way it's a little more obvious that we're storing the frame package and then we're incrementing recorded time by that much. Now, because we just added a frame package to our data, we know that we're not out of data, so we can safely say out of data, be out of data equals false. Okay, so what this takes care of is storing data. And just to recap, what we're doing is we're getting the components that belong to the owner, and we're specifying only to get the static mesh components. We're checking to see if that array is greater than 0. If it is, we get that first element and cast it to a static mesh component. We check to see if that static mesh component is valid, if it's not null. And if that is the case, we create a new frame package passing in the owner's location, the owner's rotation, and the owner's static mesh component linear velocity and the static mesh component angular velocity, as well as the current delta time. And then we have that frame package. We're ready to add it to our list. But first we check to see if the list has a recorded time less than 15 seconds. If so, then good. We'll add the frame package to the tail of the list, and we'll increment our recorded time by delta time. Now again, if you want to be a little more obvious that this delta time corresponds to the frame package, we could replace this by package.delta time. They're the same value because, again, we just created the package and passed in delta time. Since we just added a frame to our frame data, we can say out of data is false. We do have data. So that's the case when recorded time is less than 15 seconds. However, if it's 15 seconds or greater, then we need to take frame packages off of the front of the list, the head of the list. These are the oldest ones. So we get the head of the list, we get the delta time from that head node. We take our stored frames and remove the head node from it. And then we reduce recorded time by the head delta time, that delta time of that node we removed. After this while loop is done, we know running time is less than 15 seconds. At that point, we add our new frame package to the list. We add to delta time, we add to recorded time the amount of time, this frame, and then we set out of data to false because we know we have data. Okay, so that's all for this if statement if we're not reversing time. But if we add an else to this, then we know here we are reversing time. But we only want to reverse time if we're not out of data. So we're going to make this an else if and say if not be out of data. So here we are reversing time. Okay, so we are, if we're not reversing time, basically we're not right-clicking, we're not holding down the right mouse button, we're gathering data. But if we are clicking, then this else will fire off, and we're also adding the extra condition that we need to make sure we're not out of data because we don't want to reverse time if we're out of data. Okay, so we're ready to add our reverse time code, and we're going to do that in the next video, so we will see you in the next video.